All right, we have a good question here. This question uses one good thing. There's a trick that you've got to use in between. So let's read the question. Three charges QQ and minus 2Q are fixed on vertices of an equilateral triangle plate of edge length A. This plate is in equilibrium between two very large plates having the surface charge density sigma 1 and sigma 2 respectively. Find the time period of small angular oscillation about an axis passing through its centroid and perpendicular to the plane. Moment of inertia of the system about this axis is L. So basically, in this question, we've been given that the system looks like this. So basically, there's this triangle arrangement. It's an equilateral triangle of side length A, and we've got plus Q and minus 2Q right here on the edges. Now basically what we've been given is that along this plane of our rectangle we have a sheet which is above this and below this. So basically what would happen is that there would be a sheet above this and just like this one below this. So basically on a sideways it would look like this. Let's take this to be sigma 1, sigma 2, and you would have this like this. So basically we have a net electric field. So electric field right here for 1 would be sigma 1 by 2 epsilon naught. So same way sigma E2 would be sigma 2 by 2 epsilon naught, and this one would be the direction of E1, this would be E2. So taking the net electric field, you would have electric field towards any side. I have no idea which side is more, so yeah, that's why there is a mod in the options, sigma 1 minus sigma 2 upon 2 epsilon naught. So this is the net electric field, right? All right, so now this becomes a question of a normal talk question for an electric field medium. So we have this particular figure and I basically have to find how much torque would act on this on a small oscillation of some angle theta, right? All right, so for this I would take, so this is the centroid out which we have I about the centroid to be L. All right, so this length would be A by root 3. So I'm gonna redraw this. All right, so after redrawing I would have a figure like this, like the complex omega and omega square. This is the equilateral triangle they make on the complex plane. Exactly, I've taken that. So let's take this to be at some a root 3 comma 0, a by root 3 comma 0. This is the minus 2q charge and I have plus q and plus q. So basically now the torque acting. So basically the main thing in this question is that when you have this point, this, let's take that the net electric field is acting inwards onto this. All right, so net electric field is this. So this is in minus k cap direction. Now the main thing in this question is that each point is a by root 3 distance from this central point, but how would it wanna rotate it? So when you have an electric field going inside the plane, so this one would apply a force minus 2q times E, right? This would be my force vector, so it would come out of the plane. All right, and this one would take force inside and this would be force inside, and obviously so this would be some 2f outside, right? So so basically you have a net force to be 0. Obviously there's 2f going inside and 2F outside. Net force is basically 0, but the torque is not 0, because this thing, so basically you have this to be the axis of rotation, and you have a by root 3 distance somewhere here, and about this would try to rotate it out of the plane, right? So if you're looking from above, this would just try to or let's just see from here, okay, in its plane it would try to move like that. So, and same way for these, so it would apply a net torque, but the problem is that these are not in the line of this. That's the main thing in the question that I missed when the first time I did it. So for that you need to, so here's the trick. What you really need to do is that when you have a bar and you want to find the net torque on it, so you take QE sine theta and QE sine theta right here. But you can't do that here, because this one would try to apply the force downwards, right? But it won't actually move exactly in the opposite direction of this, because this is a root 3 distance at some angle theta from here, not exactly a root 3 distance. So that's the problem. So so let's just break its rotation into two parts. All right, so one rotation, so basically it's going to have a rotation along the y-axis, and one is going to be around along the x-axis. All right, so this a by root 3 point is at angle, so the total angle was 120 degrees, so this would be 60 degrees, so this is pi by 3 angle. So at some pi by 3 angle, this would be a by root 3 sine pi by 3, sine pi by 3, and this is a by root 3 cos pi by 3, and same for the one below this, right? So this was omega and this is omega square. I've taken one more and this would be doubled, right? So now in my original question I had this system which was trying to rotate it along this, so it was gonna rotate like this, but uh, the y-axis it's just gonna hinder in the but it's not gonna act as an SHM equation, right? So for that I just need to look at the x-axis, right? So for the x-axis I can say the net torque applied on this would be 2q times E, right? And in the same sense, okay, so the net torque for this type of movement, this exact type of movement on this 2q charge would tend to move it out of the plane, right? So this would be some plus k cap. All right, and same way, so basically it would try to move it around this, and when you apply the right hand rule you would have the torque in I cap direction, and same in this, that's why you add the torques up, right? So now when you take the vector, so you would have a by root 3 times q cos pi by 3 plus this same thing twice because of the second charge, right? Both would have pi by 3 angle between it, and cos pi by 3 and 2 would cancel out, and you would have a q by root 3. This is the total sorry times E. So this is the total net torque, my bad. So this is for the q charges. So and when you look at this, so the figure would look like something like this, and this would just try to move sorry, my bad, this would try to move out of the plane and this would try to go inside the plane. So let's just make it a proper dipole, and for this dipole, now look, it's literally a dipole. Now this is plus 2q charge and this is minus 2q charge, right? So I have aq by root 3 times E, plus here I had 2q times E, right? And multiplied by a by root 3, obviously the distance from the center, right? So this would be 2q E times a by root 3. So when you take A, Q, E common, you would have total 3 by root 3, which is root 3 A, Q, E. Now if you divide by electric field, you would get the net dipole moment. So if you just take a net dipole instead of this whole system, you just replace this by adding these vectorially, you would get a dipole, and the dipole would have dipole moment to be root 3 aq, right? All right, so the net torque is obviously P cross E, which would be root 3 aq E sine theta. And for small oscillations, you can write this as root 3 aqe sine theta to be I omega square theta, where I is L. And for small rotation, obviously sine theta would be approximately theta, and omega square would be root 3 aqe upon L. But I think I'm missing one thing. Is there supposed to be a factor of 2 or something? I feel so. Oh no, yeah, it's fine, yeah. So this is my omega square, right? So time is just, oh sorry, it's omega now. I took the root, so 2 pi by omega should be 2 pi L by root 3 aqe. Now substituting the value of electric field that I took before, which was E is equal to mod sigma 1 minus sigma 2 upon 2 epsilon naught, I would have electric field, and I can put this into my original equation. This would be root 3 a q sigma 1 minus sigma 2 and 2 epsilon naught right here. So this should give me the C option. This is the right answer, and it's a pretty easy question. It's just this trick of taking this dipole, this net dipole, and just converting it into something else. Yeah, so you can just take the net 2QE from here, and QE times A by root 3 twice times cos pi by 3. This was the net torque on this side, and moving in the same sense. So when you look from above, it's just gonna move here and here. So you just add them up. Cos pi by 3 would be cancelled, and this would be AQE by root 3 plus 2 AQE by root 3. Net is root 3 AQE. And when you take small oscillations, when you move the rod, so initially you have QE and QE, but when you move by a small angle theta, you have a QE sine theta factor, which I took at the end. So there was a sine theta here, and you just equated it to I omega square theta, and rest you know. This how I took the electric field. Electric field was nothing, just E1 minus E2, right? So sigma 1 by 2 epsilon naught I cap minus sigma 2 by 2 epsilon naught I cap, minus because it would be minus I cap, and you would have sigma 1 minus sigma 2 by 2 epsilon naught I cap. But I don't know which side is more electron dense, so I would just apply a mod. So I don't know actually which side it would make the oscillations. So yeah, that is the question. Pretty good at the end. So this is your answer. Thank you very much.